The Hummel Optigauge test system is the first optical testing machine for fully automatic, complete testing of implant screws. Different types of screws are tested for their dimensional accuracy and the presence of qualitative faults. The Hummel Optigauge test system is designed as a compact standalone device in modular structure. The screws are loaded either in bulk or in workpiece magazines, depending on their size. A fast, high-precision robot takes care of system internal part handling. This makes the system extremely flexible in terms of part loading and unloading. It is also easy to implement additional modules. The Hummel Optigauge test system can be used to test all relevant parameters of bone screws very quickly and reliably. The screw head is tested to find out whether the geometric features, such as square or slot size, for example, have been manufactured with dimensional accuracy. It is also tested whether the screw head is free from undesirable surface damage. It is also checked whether the base of the bore is free of chips. The thread of the bone screws is also checked for flaws. Deformation of the thread turns is detected and the dimensional accuracy of the thread is checked. The free cutting groove is checked for burr and correct manufacture. Small screws are loaded into the system as sorted bulk goods. The feeder system transports and singles the screws and positions them precisely in the first station. The screw head is tested first in this station. To do so, the high-resolution special camera is brought into position above the screw head. The camera takes 3 pictures, 2 different lit pictures of the screw head cap and another picture of the bore base. Using the first picture of the screw head cap, a highly accurate dimension test of the square, slot or crosshead geometry is made. The second picture of the screw head cap and the picture of the bore base are used for qualitative evaluation of the head surface and bore base. By using special measuring algorithms developed specially for this job, the necessary measuring accuracy is achieved. At the same time, the measuring method ensures that slight deviations from the nominal form, which are insignificant for the screw's application, for not lead to the screw being tested as not okay. You will now see some examples of typical defects. Double square. Square head with dent. Square without chips in the bore. Square with chips in the bore. Square missing. Slot deformed. If the screw heads are defective, the screws are already sorted out after this first station. The robot now picks up the screws with a perfect dimensionally accurate head with a suction grip and transport them to the next station. In the second station, the screw thread and the head taper are tested for qualitative defects. To do this, the robot turns the screw completely around its own axis twice. 2 pictures are taken, one of which is used to test the thread and the other to test the head taper. To pick up both zones optimally, different lightings are also used here. You will now see a few examples of defects. Thread defects. Burr on free cutting groove. The robot throws screws with defective thread or head taper into a separate waste bin. The robot then positions the screws without defects in the third station. In this station, the screw is checked for dimensional accuracy of the thread. Characteristics such as screw length, thread core diameter, external diameter, tip angle and taper angle are measured. The extremely precise Hommelwerke Contour 202 measuring system is used for making the measurements. The robot places the fully tested fault-free screws either in bulk containers or in single packages on pallets. Here too, the Hommel Optigauge test system demonstrates how flexible it is and enables different customer requirements to be met. Despite its complex system structure and the large number of test characteristics, the device is still easy to operate. The evaluation and operating software has already proven itself in a number of similar applications. It is switched over to different screw types by loading the appropriate test data records. Existing data records can simply be copied or adapted when new screw types are added. Another excellent feature of the Hommel Optigauge test system is the extensive documentation of the measuring and test results using automatically generated test logs. In addition, the statistical data can be entered in a customized statistics program via a data interface. A QS-Stat evaluation is also available as an option. The flexible module concept of the Hommel Optigauge test system and the use of a robot for the part handling provides a number of interesting options. For example, it is possible to integrate additional measuring functions, such as the tactile measurement of the bore depth. Laser labeling components, which may be necessary, can also be linked.